All right, guys, so we're going to approach graphing this problem. Let's say the domain and range for the end. We find x-intercepts by plugging in 0 for y. So when I plug in 0 here into y, I'm going to get 0 equals x cubed over x squared minus 1. And when I cross multiply, look at this fancy thing. When I cross multiply, those are just going to cancel. So now it becomes just 0 equals x cubed. So therefore x equals 0. So both my x and y intercepts are 0, 0. Because I plugged in 0 for y and I got 0 for x. So x and y intercepts are 0, 0. Okay, how do I find critical numbers? Set the first derivative equal to 0 or set the first derivative equal to undefined, right? Real quick, before I get to that, I got too excited. I want to answer the vertical asymptote, horizontal asymptote, slant asymptote, because I don't need derivatives for that. Look up on the screen. What makes, doesn't the vertical asymptotes, isn't that what makes my denominator 0? What gives me 0 my denominator? When x is what? 1 or negative 1. So my vertical asymptotes would be x equals plus or minus 1. What about horizontal asymptotes? The numerator's degree is bigger, so what's that tell me? What's that mean? Well, come on, you guys are all in pre-calc. If the numerator is bigger, all right, here's it. Degrees are the same, leading coefficients. Degree bigger in the denominator, y equals 0. Degree bigger in the numerator, there isn't one. Now, what's the difference in the degree? Because the degree is bigger by 1 in the numerator, what do we now know there is, though? There's a what? Say it louder, I hear it. There's a slant asymptote. So what I need to do is I need to take x cubed and divide it by x squared minus 1. So what times x squared? X times x cubed minus x. So that's going to give me a remainder of x. But this is what you know. This x right here. So the equation of my slant asymptote is y equals x. I'm going to go to my graph and I'm going to graph my asymptotes. I have a vertical asymptote at negative 1. I have a vertical asymptote at positive 1. I also have a slant asymptote at y equals x, which would be this and this. But what I know this, and we'll review here, I'm going to erase the middle part because the slant asymptotes are to the left and to the right. I also know that because I have an xy intercept at 0, 0. So I'm going to go ahead and plot that point. So that's what I know. I know that's a lot of review there, and I'm not going to hold you super accountable to it. Do you guys remember slant asymptotes now? How you get that? Degree 1, you divide and go from there. I was telling Mr. Dotson this yesterday, Ms. Wingler and Mr. Lyon, like, they don't remember slant asymptotes at all, and they're all ticked off at you. So if you see Dotson, he punches you, it's probably, who had Mr. Dotson? He's like, he can't believe that you guys don't remember that at all. Do you guys remember it?
We briefly went over it.
You briefly went over it. So that's on recording. Mr. Dotson, Nate Line said you briefly went over how to find a slant asymptote. Victor Gastelum is backpedaling right now. He wants no part of that. All right, so let's go now to critical numbers. I know I got a little ahead of myself there. I'm going to erase this work just to have room of the slant asymptote, so I'm going to erase that part. And I'm going to come back in here. And we find critical numbers by saying the derivative equal to 0. So I'm going to set x squared times x squared minus 3 equal to 0. I already found that x equals 0. And x squared minus 3 equals 0. So x squared equals 3 So therefore x equals plus or minus square root of 3. But I also, for critical numbers, have to find where the derivative is undefined. And isn't the derivative undefined when the denominator of the derivative is equal to 0? So I also set x squared minus 1 quantity squared equal to 0. Okay, and that gives me x equals plus or minus 1 again. But we're going to stop for a second. We already know that x equals plus or minus 1 will not be relative maximums, so I don't care about them. Because they're what? They're vertical asymptotes. But they still fall under the category of what a critical number is, because the definition is where the derivative is equal to 0 and the derivative is undefined. So I have x equals 0, plus or minus square root of 3, and plus or minus 1. Questions over how I found the critical numbers? Okay. Again now, I'm going to erase that work just to have room. So I'm going to erase all this critical number. And now we're going to talk about PPIs, which is when the second derivative, those are possible points of inflection. That is when the second derivative is equal to 0 or undefined. You all should know it. When is your denominator undefined again? At what? Plus or minus 1. Okay? I know they're not PIs though, are they? Because they're what? Vertical asymptotes. But I also set that 2x times x squared plus 3 equal to 0. So I get 2x equals 0, and I get x squared plus 3 equal to 0. On the left-hand side, that gives me x equals 0. Over here, aren't these imaginary solutions? We're not going to graph imaginary solutions, okay? We're talking about the real zeros. So to be honest with you, I know my PPIs are plus or minus 1 and 0, but we already can eliminate the plus or minus 1 because we know they're vertical asymptotes. And what we're going to do now is we're going to go to this table and we're going to create our intervals from left to right of critical numbers and PPIs. Y'all with me? So I'm going to go from negative infinity to, what's my first one? Negative square root of 3, right? Make sure I'm doing this right. I'm going to go from negative square root of 3 to negative 1. I'm going to go from negative 1 to 0. I'm going to go from 0 to 1. Looks like we're going to have to add on to our table here. We're going to have to go from 1 to square root of 3 and one more. From square root of 3 to infinity. We've got a lot going on there, don't we? And what I recommend doing is, again, right now, before we start checking for positive or negative, did you guys kind of do the same thing too in your quiz? You didn't have to. I like to write above each of my intervals a test point that I'm plugging in. You didn't have to, but I just think it helps you keep things organized. So let's see here. I'm going to plug in negative 2. I'll help you out here. Isn't negative square root of 3 like negative 1.7? So how about negative 3 halves, like negative 1.5? Here, how about negative 1/2? How about 1/2, 1.5, and 2? And we're going to plug those into the derivative. Because if our derivative is positive, we know our function is increasing. And if our derivative is negative, we know it's decreasing. And then we're going to plug into the second derivative because the positive second derivative tells me concave up, whereas second derivative is negative tells me concave down. We okay? I'm going to help you with the signs for sake of time, and I can see it in your eyes. You're spent. You're worried about your quiz. You're drained. So here we go. Plus, negative, 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 positive, and then negative, negative, positive, negative, positive, positive. So that tells me then in these intervals, let's go ahead and say this. In this interval from negative infinity to negative 3, it's increasing concave down, decreasing concave down, decreasing concave down, decreasing. If I write something wrong, tell me.
Shouldn't it be concave up?
See? If I write something wrong, tell me. Decreasing. Whoa, what just happened there? So again, concave up, thank you. Decreasing concave up and increasing concave up. Yes? So then let me ask you this question. Where do I have a relative max or a relative min? And I'm going to give you a hint on just one thing. Remember, this is a vertical asymptote occurring here and here. Okay? So, what's this right here? Negative square root of 3. That's a what? Relative. It's a relative max, isn't it? You go from increasing to decreasing. So I have a relative max at negative square root of 3 comma something. We'll find this something here in a second, okay? And I have a relative min. I'm decreasing then increasing at square root of 3. So square root of 3 comma something. Let's also talk about points of inflection. Do I have a point of inflection anywhere? Now I know what the students make the mistake here. They try to tell me there's a point of inflection here. The problem is this is a what right here, guys? Vertical asymptote. So there's not a, and so therefore there also would not be a point of inflection here at positive 1. But there is a point of inflection where? 0. So we know that point at 0 comma 0. Okay, I'm going to stop for a second. Questions? All right. Now, when I plug in square root of 3 here, I get square root of 3 cubed, which is 3 square root of 3. And what's square root of 3 squared? 3 minus 1, which is 2. So, how about 3 square root of 3 over 2? And then when I plug in a negative square root of 3, it's just going to become negative 3 square root of 3 all over 2. Okay? Now, why don't you let me graph it and let you guys get an idea. I think anybody got a calculator right there in front of them? I think 3 square root of 3 divided by 2 is like 2.7 something. Can you guys check me on that real quick? One of you, can you please dig out your calculator and type that in for me? I will wait. Michelle's got it right here. I'll let her crunch it. 3 square root of 3 divided by 2. Let's see. It'll be 3 times 1.7 something divided by, I think I'm right.
2.598.
Okay, so just write it 2.5, right? So, here we go. I was a little off. So wouldn't I have a relative max at 1 point, wait a minute, 1.7 something, comma 2.5. So I'm going to come in here and see if I can graph that. 1.7 something, comma 2.5. Oh, that's about right there. And then negative 1.7 something, comma negative 2.5. Oh, that's about right there. And isn't this a relative min right here that's concave up? Look at it. I have a relative min that's always concave up. And it's approaching these two asymptotes. This is a relative max that's concave down that's approaching those two asymptotes. in honors pre-calc, would you do some this complicated, Ellie? Who else was in there? Abby? Do you guys kind of recall maybe some this complicated? You didn't understand the relative max and mins. You didn't understand the concavity that you could do all this. Now look at this middle part. From -1 to 1, it's always decreasing, and it's concave. Where am I? I'm sorry, right here. It's always decreasing. It's concave up to concave down. It looks like this. So here it's decreasing, concave up, decreasing, concave down, and there at 0, 0 is that point of inflection. We just did a lot right there, didn't we, man? Okay, domain, negative infinity to -1. -1 to 1 and 1 to infinity. Yes? Son of a gun. Whew. I got scared. Did you see it? It all disappeared for a second. I'd like to point out how well I showed my restraint on my video there. You throw the iPad.
Technical difficulties.
Yeah. I was about ready to flip out. I'm not gonna lie. What's my range? From negative infinity to infinity. This is the most constrained JT has ever been in his life. The recording right now says 16 minutes and 51 seconds. Quiet. Yeah, there you go. Be quiet. Questions?